Going live. All right. Welcome everybody to the platform sprint review. My name is Balázs Bézi. I'm supporting the platform teams, and today we are going to give you a quick update on our progress. We are planning this event, this session for 60 minutes, and it also depends, the length of the session also depends on your questions, which I am highly encouraging you to ask your questions in a chat, in the comments, in the live chat below. And also, please make sure you include the context of that question, because at the very end, when we are going to have a Q&A session, it would be really hard to answer the short questions without any context. So please make sure that at the very end, when we are going to get back to your questions, make sure that we still can understand those. So put the context in as well. Thanks. And also, if you have any feedback, comments, let us know. That is highly important for us to get feedback from you. All right. Without further ado, let me give the words to our first team, which is TenderDash.
Well, hello everyone. I'm Dmitry Golubev, software developer at TenderDash team. And let me do a quick update about the current progress of our team. Well, first, we made a pre-release of TenderDash with ABCI++. Now it can be used for development by Drive team. And this release, only with this release, doesn't include word extensions improvement. However, we are going to deliver it very, very soon. Second topic is, as a planet, we finished working on withdrawal transaction with using word extensions. And now TenderDash is ready for a new pre-release that will include word extension improvements. So basically on the sprint, we're going to do it. And as a second step, word extension will be available from there. Third topic is validator key verification is in progress. Well, the current task is on the code review, and further work on this task was postponed until 14 July because the developer who is on this task on vacation. And the last topic is unplanned, like a bonus. We started working on actualization pull request that was created 3 or 4 months ago about integration TenderDash with the Go bindings for BLS library version 1. The reason why we are working on it is the code base that was changed a lot for the last 4 months. And the first goal is actualize code base, and the second one is make some improvement and fixes which we already identified. So yeah, pretty much it from my side.
Maybe Dim, you should tell people what BLS is.
Yeah.
Oh, BLS, you want me to?
Yeah. BLS library is the new version of BLS library includes some improvement. In particular, it's kind of completely changed the API and also input and output of private keys and other stuff which related for the threshold signature. So we use this library in order to create threshold public key, which is used across our DKG. This is the reason why we're working on it. And very, very soon, as I'm correct, the Dash core will also migrate a new version of BLS library, and we also should support it. And we kind of did some effort in order to, like a pre-merge, one core will kind of migrate. We already have everything to do it quite fast. So this is the reason.
Well, that's great. I do want to tell people in the audience that why it's called BLS V1. We're currently using a version that's pre V1. So we've been using since 2018 a version of BLS that was, I think, 0.1. So we've decided in version 19 of Core to migrate over to a new version of BLS. So it needs to be supported in all of our products.
Yeah.
Yeah, thank you. And what's next for Tender Dash?
Well, the first topic is finalization, working on integration goal bindings for BLS1. Yeah, the second is pre-release, as already mentioned, pre-release ABCI++ with improvement for WOT extension. Also, we have to update WOT extension specification in ABCI++ on our side, of course, because we completely changed it. This part of contract between ABCI application and Tender Dash. And the last topic is research sandbox execution. Well, yeah, we are going to start on it because all work which we finished, and we already had a kind of a plan. So finish first backport, new version of Tendermint. Second one, do some improvement and related to the WOT extensions. And the next step should be sandbox execution, because we already prepared everything for this one.
Thank you, Dima. Yeah.
I'm just going to go. I'm going to be translating for our audience again.
Okay, thank you.
Just so if people are not very, very technical, so they can understand. ABCI, so you can see Tender Dash as the consensus engine, protocol as the client that kind of uses the consensus engine. The client is called the ABCI application blockchain interface, I think. So basically ABCI client is protocol, and ABCI++ is the next version. It was a term coined by Tendermint, which is basically a very big improvement on the current ABCI structure. So we've been backporting that. One of the later features is same block execution. So we're working on that as well. And same block execution is basically needed for our system. It's one of the main goals of Tender Dash now. Okay.
Thank you. And let's continue with GroveDB.
Hey guys.
Wisdom.
Wisdom from the GroveDB team. So this sprint, we worked on multi-query proof generation and verification. This allows you to request a proof for multiple queries at once and get the full result set. This was needed by Drive during integration to achieve some of their functionalities and requirements. Another thing, so we have done the version 1 of this that allows Drive to integrate, but then there are some edge cases that we need to handle before we can consider this done. And this deals with merging of subqueries and conditional subqueries. So the simple use cases work, but then we still need to do some work to make it finalized. Another thing we worked on was proof of path absence. Proof of path absence is before, when you request a proof for a path that points to no subtree, we return an error telling you that this path points to no subtree. But then the proof is actually supposed to prove to you that that path really doesn't point to any subtree. So this task basically achieved that, and that is done. Proof documentation, we couldn't work on it this sprint, so it's still in progress, and hopefully we can get onto it next sprint. So I'll move on to Sam to talk about batches.
Yes. So I was a little bit busy working on version 2 of batches in the sprint. It 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 works a little bit differently. In the past, we had used a red-black tree, but there was a more efficient way. And so the more efficient way is basic. Well, before we start there, what are batches? When you insert data into the database, you can either insert them like one at a time, or you can insert multiple things atomically and just say like, hello, I'd like to push this piece of information, this piece of information, this piece of information, and do it all in one batch. It makes the system much more fast, which will eventually increase our transactions per second. It also, when you push everything at once, it pushes it in an atomic way. So if one thing fails, the whole thing fails. And that's very important. So yeah, how did batches v2 work? It's basically when you're pushing different things on multiple paths, it creates an overall path structure of all your batches. And then it, GroveDB actually, we can think of it as a 3-dimensional tree. Basically, you have your two dimensions, left, right, left, right, left, right, left, right, that are, it's an AVL tree, so they're also rotating inside that dimension. And then the next dimension is like front left, the front back, where each node can actually be a tree that references another tree. So that's why is this important? Oh yes, when inserting, basically you have to create a path, like a whole tree, secondary tree structure of all your inserts, so that like when you insert things, if you insert something under, when I say under, it's like maybe in front or under another tree, you basically have to update the hash of the parent as it's inserting. So that might be a little long-winded explanation, but basically that was done. We are experiencing an issue with it in review, so we're investigating that right now. That's why it's not done. So with that, I'll pass it to Evgeny, who worked on cost for storage.
Thank you, Sam. I think I forgot to mention that batches v2 are way more faster. That's great.
Yeah.
But back to costs, and a quick explanation why we're doing it, because one may say that we have costs on previous sprints, and that's true. Indeed, on first iteration, some time ago, costs were computed using the high-level knowledge of how things work in GroveDB. So basically, developers did that. But we should make computers do that work for developers, because software constantly changes and we may lose something in accuracy. That's how in a couple of last sprints, we made a cost framework to integrate it into all code path that we have. And we use it for fees, and to set up a new GroveDB API, which will include this cost information. And so we did this integration until Merck level, just to do it in a shorter time span. But it's not done, and even better solution is to start collecting costs on storage level, as it will happen directly in that places where most of these metrics come from, like bytes written and loaded, number of SIGs, and even hashes. So it's currently in progress, and the status is done for storage and in process of fixing broken APIs on upper levels. I mean, Merck and GroveDB. So yeah, that's basically it for costs, for storage, and the whole story for GroveDB costs. Thank you.
Thank you very much. Thank you very much. Let's continue with SDK team, and may I pass it to Mikhail. Oh no, that shouldn't be the next slide. Oh, this one. Yeah, what's next? I'm sorry. And I should give the word back to Sam.
Yeah, I'll take it. So when we started off GroveDB, we were not as familiar with the project. Sometimes they say the best time to write a project is when you finish it, and that's definitely true. We originally built in this root tree, which was a dense Merkle tree, and we did that. I don't remember why it was done. Probably because AVL trees were not as we were not as familiar as we needed to be, or some reason. But in the end, the AVL tree is just so much more efficient than a dense Merkle tree. So, and it does not make sense to actually have the dense Merkle tree as the root tree. So we basically are going to switch and standardize, and then GroveDB will only be using one type of tree for now. Probably we will insert other types of trees for specific features in the future, but for the root tree, it just makes more sense to use an AVL tree. So that's one thing that we'll work on. Efficient references. Efficient references will basically, right now in tree nodes, basically you could have a reference to, when you have a reference to another element, like an item, the reference is on an absolute path. And if we change that to a slightly relative path or a height relative path, we'll be saving a lot of storage space. And that will in turn lower the costs for transactions. And that's the whole point. As we've been doing these costs, we've been seeing that as we're getting closer, the costs are pretty high. So we're trying to find relatively high, still massively cheaper than Ethereum and most of our potential competitors. However, still not as cheap as we'd like for mainstream adoption. So we're trying to find ways to reduce, to make just the system a little bit more efficient, kind of like low-hanging fruit, easy tasks. So our fees out the gate can be a little bit lower. And then, yeah, so also in the next sprint, as people saw, we still have some tasks that aren't completely done. So we have to finish those.
Thank you very much. Now for Rio, Mikhail.
Hey everyone, I'm Mikhail from SDK team. And this sprint, we were mainly focused on three things, which is rework of chain synchronization process, SDK repository documentation updates, and stabilizing Dashmate. There was tons of debugging the Dashmate and its setup. We checked many cases with the Dashmate. Dashmate is the tool which is used to manage local node setups and local network, local platform network. So we filed up a troubleshoot section for that, and also added more documentation for it to make it more easier for users. Also, we finally upgraded to the Docker Compose v2 and merged it into v23 branch. v23 will be soon, very soon, and Docker Compose v2 will be also merged into the main release. So the point of this upgrade is to use new Docker Compose syntax, which have more benefits over the legacy Docker Compose binary. Compose v2 is already bundled in the Docker. So also we added a flag for moving the storage of the file set for platform test suite. This is more like used in our tests. Yeah, and is more like for development purposes. Yeah, kind of like that. Still investigating, still working on Dashmate, and it's issued during setup. So soon it will be much more clearer for the users when they work with it. Yeah, that's it from my side. I
Thank
pass
you.
it to Igor.
Thank you, Mikhail. So in this sprint, I was busy reworking wallet synchronization and making a proper chain and block headers and transactions verification against each other and so on. I must say I'm very happy that I have these low-level blockchain fundamental tasks to do, but I'm not super happy I have to do them in JavaScript. And this will be first bullet point I'll be speaking about. So during the development, I found out that in order to simply calculate hashes of 700,000 block headers and testnet takes around 10 minutes because our X11 hash library is written in JavaScript. And this is kind of, well, I wouldn't say it's not acceptable, but it will slow down synchronization process a lot. Plus additional 10 minutes, right? Not a very good number. So we decided to get our X11 library written in C and make a WASM bindings for that. Make a WASM build and WASM bindings. I will quickly share what we did in that regard. Let me share my screen. Okay. So there are two terminal windows, and I wrote a simple benchmarking tool, and I will show you what is the outcome of this effort. At the left side, I'm starting the benchmark for JavaScript X11 library. So you can see the estimated time to finish that is around 900 seconds. It jumps back and forth, but in general, it's on my machine when it's not loaded much, it's about 600 seconds, making it 10 minutes, right? And I will start WASM benchmark at the right side. The numbers here are quite jumpy for some reason, but eventually it stabilizes and gets to about 70 seconds to finalize, to finish the job. And as you can see, JavaScript made only 3%, while WASM already made 15%. This is pretty much it for this part of the demo. We won't wait until it finished, and I will show one more thing where it actually where this change impacts the most. Let me pick a different target for a screen share. So yeah, actually the library is out. We released this to NPM, is available for the downloading, and it already has 85 downloads since Friday. Not sure where that from comes, but I don't know, maybe some bots picking this up. But anyway, getting back to the wallet synchronization library, I made a small demo to illustrate what I did so far. Behind this small model window is JavaScript wallet for Dash, and I will start synchronizing the chain and show you what we have so far. It needs a couple of seconds to pick the change status, and yeah, actually this is already kicked in. So the blue progress shows how many block headers we fetched from the network and verified against each other. And 0 bar says that, and now it's 1%. And green circle, if you see that on your screen, small green sector, is the progress of confirmed transactions that already passed through block headers verification, got their Merkle blocks verified, and so on and so forth. So as you see, the blue circle is already made it to half. And if we had JavaScript X11 library, we had to wait like 10 minutes for that. There are still some performance issues with that because in general, these verifications are resource intensive, and basically having command and JavaScript is single threaded, they are kind of blocking the UI thread. I'm not sure whether you see that, but the animation not so smooth. It hangs a little bit once in a while. So this would be ultimate goal for the next sprint and the sprint afterwards to make it, to stabilize it, to make it work with the storage, and yeah, finally to have a proper synchronization process for wallet. This is it from my side. Balázs, I think we could get back to presentation. And yeah, as I said, what's next? We continue reworking chain synchronization process, and we also continue updating documentation for SDK. Thank you.
Thank you. Let's move on and continue with the protocol. And I'm asking Sam to start here with the fee calculation.
Yes. So one thing that's been being worked on for quite some time and wasn't heavily worked on this sprint, but still worked on was the worst case fees. One of the things that we realized was the way we were doing worst case fees wasn't ideal, and that's why we are doing it at a lower level, like Evgeny talked about earlier. So a lot of the work that was done was just wrong. It was, sometimes you make mistakes, and this is one. And so we're working on a different approach. The new approach is basically collect all the batch operations that a specific thing will do, and then apply those batch operations, but not apply. I'm sorry. So if it's the worst case for each batch operation, figure out what the worst possible case for that batch operation could be. That's being done. It's closer than it's ever been. We still have some issues with deletion, where it's a little bit complicated to the way deletion works is you have if you delete an element in the tree, it will automatically delete empty roots up the tree. And that's hard to do in a worst case scenario. So that's kind of the last big thing that needs to happen. The second one is fixed non-deterministic fees for data contract cache. Yeah, there was an issue of non-determinism because our cache had a specific amount of space, and it could be that in one node the cache had the contract, and another node it wouldn't, which would have led to a different fee on two different nodes, and in turn that would have stalled our chain. So we figured that one out, and we fixed it. The next one is GroveDB batches integration. As I said earlier, we integrated batches into RSDrive. That's done. there's just an issue with batches. So in RSDrive, there's a flip, there's a switch, put batches on or off. With it on, it doesn't work in one specific case that we're currently looking at having to do with a combination of proofs. Most likely it's not a problem in proof and it's more of a problem in batches, but we have to figure that out. But it is integrated at this point.
And Ivan, can you jump in?
Or Javid?
Probably I should. Hello.
Yeah. Hey, Javid.
Javid from Platform is here. So about the fee distribution pools. So this sprint, we've been working on heavily on the distribution to like payout to the identities, as well as the distribution of the fees throughout the 50 years of epochs. And the third thing which we do is we've been extensively working on doing more and more test cases for people. So we thoroughly test the whole thing. And the work mostly been on the Rust side of things. So it's a RSDrive project. And we haven't touched the platform for integration yet, although the work has been started, but not much have been done there. So that's kind of what we've been doing on fee pools this sprint, without getting too much in technical details, I guess. Ivan, have you anything to add?
Yeah, I would just mention why we need these pools. What's that? We already talked about that in our previous sprint reviews, but just in case if someone don't know. So state transition fees are not distributing immediately because it's not actually efficient approach. So we're collecting these fees for storage, for processing in the specialized pools. And then every epoch, it's like some time window, we call it epoch, it's like about like 18 days. We collect these fees and then distribute them among active master nodes and master node shares. Yeah, and you probably noticed that it's in review even since previous live review what we made 2 weeks ago. The reason is that during review we just encountered a few interesting problems like floating point non-determinism issue and so basically the financial math is pretty interesting. That's for sure. And we want to be really careful when we wanting like working with these credits. So they shouldn't disappear, or the balance is credits to dust shouldn't be should stay. And yeah, and we're trying to figure out how to basically to keep all the fractals after the calculations and keep all the place. Thank you.
Thanks for help.
Sure.
Yeah, thank you very much for the rationale here. Kostya.
Hi everyone, my name is Konstantin. Let's start. So the first one, simplify public key to identity structure and remove get identity IDs by public key hash. We changed the structure to make it more efficient. The previous structure had some issues. It didn't allow to implement efficient proofs since it required proofs for both identities and public keys. to respond with identities, separate read from storage required for each identity. What else? Identity IDs were stored as seaboard array, and because of that, it was needed to read the whole globe every time. And that made it impossible to predict fees because we didn't know how many IDs are already there. And in case if we had too many IDs, it wasn't possible to implement pagination as well. Now we have a subtree with identities under the keys, and it solves all these problems. And we also removed unused and necessary get identity IDs by public key hash and point. Provide proofs from DAPI. We finally re-enabled proofs in our endpoints, so now you can get proofs from Drive again. So next slide, please. Yeah. Allow a child document type and property name in DPP. Previously, we had a minimum 3 symbols because of the MongoDB related restrictions. And there was a request from the incubator to change the minimum to 1 symbol. And since we don't use MongoDB anymore, and it was pretty simple change, so we changed it from 3 to 1. Lock synchronize masternode identities in Drive. This lock is for debug purposes. I would like to have an opportunity to know how the process is going, to have more information during our upcoming investigations and bug fixings. So it would be helpful to have such information. And the last one, fixed uncertain transaction rollback. Due to untested, so the thing is that in real conditions, sometimes transaction could not be rolled back, and we hope that this fix should solve the problem that we had. That's it.
Thank you.
Probably I would summarize what we're going to do next in upcoming sprint. So as Samuel already mentioned, we're really close to accomplish the fee prediction and calculation. We're close to finish the pools. So that's what we want to focus next sprint, particularly on a fee system. And it will be the last feature before the V23 release of the platform. So we have the main features. We have proofs, right? We have fee system and complete identities, right? The complete identity functionality according to DEEP11. Yeah. So we're gonna prepare this release, do some integrational tests and test on internal DevNets with our mobile teams and prepare release for testnet. Also, we will start to do some version, like the work which is planned for version 24. Next sprint is integration of ABCI++ protocol. So Dim already talked about that. It's a protocol, basically the communication between consensus library Tenderdash and blockchain runtime itself. And it's makes many things easier and more efficient. So we need to adapt it to new. We need to adapt the new version of Tenderdash. That's our plans. Thank you.
Thank you. So let's talk about the Rustport.
Yep. Hey guys, Anton's here. And I'm going to start by saying that our work this sprint was a little bit different from previous sprints in that sense that previously we just rewrote some code from platform protocol to make it work. And this sprint, we actually started some work on integration of this new DPP into the actual platform code base that exists right now, namely RSDrive. So let me tell you a little bit about how this happened and what does that mean for the future progress of the Rust rewrite. So we've took a look at the existing code that's written in Rust, namely RSDrive, and then we've noticed that there is a lot of features that are needed in RSDrive from the protocol right now, and then re-implementing them in RSDrive means just duplication of efforts because we are going to replace it with the DPP library anyway. And so what we did, we wrote some tests to make sure that serialization is deterministic on the Rust DPP rewrite and works exactly the same way as it does in JS DPP. So meaning it has a backward compatibility with the JavaScript ecosystem we have right now, with the JavaScript SDK for the browsers, as well as Drive and DAPI components of the platform. And we wrote some tests. We figured out that there are some discrepancies there, and we fixed them. And we've tried to, well, not tried, but we started to look into what's needed to start using DPP in the RSDrive. And so what that means is that probably the next sprint RSDrive will already use the new DPP. We'll see about that. And can you go please to the next slide? Yep, thanks. So as you can see, the progress itself, the number isn't that high, and it's not even 100% complete in terms of features. But that shouldn't be scary because we will actually use Rust DPP on platform even before the red bar hits 80%, because some parts of the protocol are already working and can be utilized right now. And this is really good because we can start to test all those things I've mentioned before. It was kind of an unexpected work this sprint. So this is why it's not really represented in this current completion number, 73%. And this is actually a very good thing that we've started doing that before we've hit 100%, because this way we actually can test that the port is working as intended even before we hit like 100% feature parity with the JavaScript implementation of DPP. And yeah, I guess that is that. That's update on the Rust rewrite. Really excited to see how it turns out. And yeah, that is it. Thank you very much, guys.
All right, thank you very much. So let's jump into the questions. We have 2 questions so far. And the first one is from Shiny Bluestone, which is, platform has been unavailable for 14 days. Any estimate when it might be resolved?
I'll take that one. Yes. So currently, what's the reason why it's unavailable is because we've been doing pretty intense tests for version 18 of core, and this has been causing platform to constantly have issues, and it's not even worth trying to solve it. But version 18 of core and those tests are a priority. I'll go quickly through what those tests are and why they're taking so long and what the issue is. So there have been a few errors on that testing front, in the sense of maybe not errors, just things took longer than expected. For example, we did one test where we wanted to test the migration from V17 to V18, but testnet had been running V18 RC4 for about 6 months or so. So when we switched to RC6, it wasn't good enough to test the migration from RC4 to RC6. We really wanted to test the migration from V17, which is what masternodes use on mainnet, to RC6. So what we did is we took 50% of the network on RC4, downgraded it to V17, and re-indexed to be able to then later upgrade it as expected. Now, what has happened here is that so the reindex took quite some time, much longer than expected, especially because it was on V17, and there were a few things that work faster on V18. So after the reindex happened, we started doing the progressive upgrade into V18. When we hit 80% and we activated Sport 23, which starts the proof of service ban of other nodes, we noticed that the nodes on V17 all got banned, which is completely normal, which is what is expected. But nodes that had been downgraded and then upgraded again were starting to get banned. But this was not the case for any nodes that were always on V18, which is very weird. And probably, well, the only reason that we can really think of at this point, after spending quite a lot of time looking at code, is that most likely the downgrade from V18 to V17 was a terrible idea, and that V18 we should have wiped and just re-downloaded the chain, because our developers never think you're going to downgrade a version. So most likely that was the problem. Right now we're investigating and making sure that we're basically creating a bunch of new nodes, installing a fresh V18, making sure that they don't get banned, fresh V17, syncing up the chain, and then increasing to V18. The problem and why this is taking so long is because syncing of chain in a normal way that mimics what masternodes on mainnet have takes a long time. If we did this in any other way, it would break our test results. Yes, we would be able to potentially speed things up by having images and other things, but it would not be completely accurate. So we're doing things a little bit slower, but more accurate to be a little bit safer. So basically the answer to the question is, once in a day, I would say, those V17 nodes have synced up, then we're gonna upgrade them to V18, turn on Sport 23, that should not ban them this time. If it doesn't ban them, then we were correct, that the downgrade was actually the issue. And at that point, we'll be like, yes, V18 works, and resume putting on platform onto it. That was a pretty long explanation.
Thank you for giving us context on this. All right, so the next question is pretty much belonging to the mobile teams, but I'm going to read it out anyway. So when will be available when will be staking available on iOS?
Yeah, that is definitely not a platform question, but sure. Well, I don't know, actually. I'd have to get in contact with the product owner of the mobile team to be able to answer that question. I do know that iOS is behind Android, and the reasoning for that was basically I was the main iOS developer up till last year, and when I became CTO, the other iOS developer also left the project, meaning we hired two new people, and they're doing quite well, but just basically not having anybody work on iOS for a few months, and then or very little work, and then those people coming up to speed put us a few months behind Android. So I would imagine that it would be only a few months away, but I don't take my word for that. Ryan really would need to answer, who is the product owner of iOS and mobile team.
All right. There's no further questions here in the chat. I would like to thank all of you. Thanks for the developers to present, and thanks for the viewers to listen to us and watch us, and you raise your questions. So thank you, and see you in 2 weeks. Bye-bye.